Welcome. This session we will learn one more way to evaluate this convolution sum. So if equation of instead of this sequence values are given, if we have equations of x of n and h of n are given, so how do we evaluate y of n, which is expressed as convolution between x of n and h of n, and that we can write as k running from minus infinity to infinity x of k h of n minus k. How do we evaluate this sum when x of n and h of n are given in functional form? So to illustrate this, let's suppose x of n is 1 by 2 raised power n u of n. So this is our sequence input, and let's suppose the impulse response of this system is 1 by 4. So the impulse response of the system is 1 by 4 raised power n u of n, and the input to that system is this. So how do we evaluate this sum? Now we can directly evaluate using this formula. So y of n will be simply k running from minus infinity to infinity x of k h of n minus k. So you can write it like this. Substitute the value of x of k. So when you substitute the value of x of k, it will be 1 by 2 raised power k, replacing n by k, u of k. Then substituting the value of h of n. Now you are replacing n by n minus k. So wherever you have n in h of n, replace that by h of n minus k. So this will be 1 by 4 n minus k u of n minus k. That's how we express this, right? So now let me rewrite first the sum, then I will do it like this. So this is 1 by 2 k. Let me write first to 1 by 4. Now 1 by 4 I can express like this, right? I can write it like this, and then I will write u of k, u of n minus k. So see, there is no n in this summation, so I can take 1 by 4 out from this sum. So this will be 1 by 4 raised power n, k running from minus infinity to infinity, 1 by 2 raised power k, 1 by 4 raised power minus k, u of k, u of n minus k. Now k is running on the summation, and we know by definition of u of k is equal to 1 when k is greater or equal to 0, or it's equal to 0 when k is less than 0. So what will happen to this summation from this? So you can say y of n is simply 1 by 4 raised power n, and this summation will now change, run from k equal to 0 to infinity, 1 by 2 raised power k, 1 by 4 is now minus k. All right, so this is uk, u of k is, we exhausted u of k there, and now we are left with u of n minus k. We used the definition here, and we got the summation running from k equal to this to this. What I'm going to do next is 1 by 4 is power n. Now I'm going to use u of n minus k. Now u of n minus k is the variable on the summation, is equal to 1 when n minus k is greater or equal to 0, or I will say when n is, this implies, let me not write the implies here, this means simply when n is greater or equal to k, since k is the variable running on this summation, I will write rk is less or equal to n. So this is equal to 1. So this sum means this is equal to 1 when k is less or equal to n. So this sum will run from k equal to 0 to n, means k is maximum value, k can go up to n, so it can go up to n. And since I am calculating the value of y of n, so you can say the sum runs from k equal to 0 to n, and then this will be 1 by 2 raised power k, 1 by 4 raised power minus k. Now let's focus on these terms. What are these terms? So this will be simply 1 by 4 raised power n, sum running from equal to 0 to n. So this will be, if I take 4 upside, this will be plus k. So this will be 1 by 2 raised power k, 4 raised power k. So you can say this is 1 by 4 raised power n, summation k running from 0 to n, and it will be 2 raised to the power k. 2 raised to the power k. So the sum is 2 raised to the power k. Now you can see this is a GP. This is a GP. This sum is a GP, and you can say k is running from 0 to n plus 1. So you can say it will be 1 by 4 raised to the power n. And this is a GP, and this will be, if I remember this sum exactly, this will be simply 2 raised power. Since the common ratio is 2, since the common ratio, this will be ratio plus last term is n, so it will be n plus 1 minus 1 divided by common ratio minus 1. So this will be equal to this. If you remember the sum of the GP, please see that. What is the sum of GP? This the ratio, where ratio is r, it will be r is for n plus 1 minus 1 divided by 2 minus 1, and this by 4 raised power n. 2 raised power n, 2 minus 1 is 2, so it will be 2 raised power n plus 1, 1. Now, how do I can simplify this? It will be 1 by, how much will be this? 1 by 2 raised power n, 1 by 2 raised power n. So you can keep it like this, or you can simplify it. You can say this will be 1 by 2 raised power n, and if you take this outside, it will be 2 raised power n. This will be, if we simplify the sum here, so it will be simply, the sum will be 1 by 2 raised power 2, that is 4 raised power n. This is 2 raised power n plus 1, 1. So this is, you can express it 2 raised power n, 1 by 2 raised power n. So this is 1 by 2 raised power n, 2 raised power n plus 1, plus 1. Now when you take it inside, when you take 1, 2 raised power n inside, what will happen? You will be left with 2. 1 by 2 raised power n. So this is the output of this system. So this is our valve. And when the impulse response of the system was, when the impulse response was 1 by 4n u of n, and input was 1 by 2n u of n. So the output is this. Now you can manipulate this and see the different forms of this output. Alright, so this is the output when the input is in the functional form. Alright, let's end it here. In the next session, we'll do the graphical approach of this convolution. How do we evaluate this graphically? Now that's also very, very important. That gives us an illustration of how many operations are embedded in this convolution sum. All right.